So last class we have discussed the role of computing in the digital world. Then we discussed what is smart IoT and how programmers and programming is very important to make our life simple. Okay. Today I will just start some fundamentals about the computers. Okay. For many of the students, this may be the redundant one, and for few of the students, this may be new. Okay. So computer, it is nothing but it's a device. Okay. Uh, that process our data into some meaningful information. It will process our data. Okay. Say for example, I want to play a video. It will do that. I am just receiving some signal. Okay, I'm just feeding some signal. There is some noise. I want to eliminate the effect of noise. Computers will do that. Okay. Computers will do that. Then but it will not do these operations automatically. We need to give some set of instructions. Okay, so computers will work based on the instructions whatever we are feeding. Okay, and it will process the input very quickly. That's very important. Okay, that is why we need computers. One minute. Then a computer can perform the following set of functions. One is it will accept the data. Okay, it will accept the data. It will store the data. Say for example, some video files or some MP3 audio files you want to store. Your computer can store whenever you want. Okay, you can retrieve the data. Then it will process the data as desired. Since you are communication engineers, I want to give some example from communication engineering. 1 minute. Say I have this particular session. Okay, I have the audio recorded for this particular session. So I'm just sitting in my room. Some background noise is there. Fan is rotating. Okay. So with all those things, okay, with the desired speed signal, okay, some noise is added, but I want to eliminate this noise. Okay, so I'm just writing some signal processing algorithms, some coding, some signal. I'm just doing some program. Okay, so that it will eliminate the effect of noise, and you will have only the speed signal. So it will process the data as desired. Okay, say for example, I have some file. I want to transmit that file. I want to send the file through email. There is a limitation in the size of the file what we are going to send through the mail. So I'm just compressing the signal, okay, before transmitting. Okay, these are some of the processing operations. Okay, so the computer can do processing. Then, as I said earlier, whenever required, we can retrieve the data. We can store the data into the computer. Okay, you can store the data. Whenever required, you can retrieve the data. Okay, then it will print the result in desired format. Say for example, I have a Word file. I want to save the Word file in PDF format. That is possible. I have some image in PNG format. I want to change that to JPEG format. That is possible. It will print the result in desired format. These are the basic functionalities of a computer. Then classifications of computer. Okay, so based on the technology what we are using, based on the technology, okay, we can classify the computer, okay, into three categories. First one is analog, second one is digital, what we are using now, and hybrid. This is the third category. This is purely based on the technology. What is the technology we are using and how it performs various tasks. So based on that, this classification, okay, we are doing. So first we will discuss digital computers. Okay. So as I said earlier, these digital computers are the modern day computers, whatever we are using. Whatever the laptops you are using, whatever the mobile phones you are using, whatever the tablets you are using, notepads you are using, all those things comes under this digital computers. Okay. So digital in the sense, these computers will understand only ones and zeros. Okay. These computers will understand only ones and zeros. Okay, this point I already discussed. So we are going to represent letters, symbols, numbers, everything in terms of binary. Okay, ones and zeros. And this is widely used in industries. Okay, under scientific business applications, scientific applications, we are using the digital computers. It has the capability of processing large amount of data. Okay, it will process large amount of data very quickly, whereas analog computers, there is a limitation. Okay, it won't process a large amount of data. We will discuss analog computers. Okay, so analog computers basically it uses the continuously changing aspects of physical phenomena. Okay, to solve the problem. Say for example, physical quantities like electrical, mechanical, and the hydraulic quantities. Okay, it will use to model the problem. A very simple example. Nowadays, in hospitals we have a digital thermometer, but earlier it is the analog thermometer. That is the example for the analog computer. Okay, it will actually it uses mercury. I think I have the picture for that. It uses mercury. So the change in the mercury level, that actually gives the reading. Okay, initially it will be here. You have to keep this in your mouth. Okay, based on the temperature, the mercury level will increase or decrease. Okay, then finally it will stay in some position. Based on that, they will measure the temperature. So this is a very simple example. If you see, I cannot do many operations with this. So it is mainly developed to measure the temperature. That's it. I cannot store other data. I cannot write a program for noise cancellation. So those things are not possible. Okay, and basically continuously changeable physical phenomena. Here it is mercury level. Okay, the level of mercury. Okay, based on that, it is measuring something. It is solving the problem. Here the problem is measuring the temperature. Okay, and this is some example of analog computer in late 1960s and early 70s. This is the desktop computer. This is purely based on analog. Okay, we are not going to discuss much about analog. That's it. Okay, just some introduction. Then hybrid computers. Okay, as the name indicates, hybrid computers, it uses both analog as well as digital. Okay, let me quickly tell. Maybe these terms may be new for many of the students. Analog in the sense, okay, the data is continuous in time. Okay, say for example, I'm just recording my speech signal. Whatever I am delivering now, I'm just recording. It will look like this. Okay, if you take any time instant, you will have some value. Whereas okay, say for example, this is at time 5 seconds. Okay, the amplitude value, if you measure 0.01 volt, something like that. Okay, for 10 second, if I measure, it will have some amplitude value. So time versus amplitude, this is continuously varying. Okay, whereas digital, I cannot give this signal as it is. I'm going to discretize this. I'm going to represent the same information in ones and zeros. Okay, this is basically analog and digital. So these hybrid computers, they use both analog and digital technology. Then why we need to combine both the technology? The basic thing is, usually the analog computers are speed. Okay, you will get the advantage of speed from the analog technology, and if you see the digital computers, it gives the accuracy. Okay, so when I am combining both analog and digital, it gives both the benefits. Okay, speed as well as accuracy. Okay, but in order to process both analog signal and digital signal, you need analog to digital converters and digital to analog converters. Okay, so you need to do more amount of work. Okay, processing with this analog to digital converters and digital to analog converters. So analog to digital converter means, if I give some sort of a continuous signal as the input, it will give ones and zeros as the output. Here it's reverse. If I give ones and zeros, it will give continuous signal, because this signal we can interpret. Ones and zeros we cannot interpret directly. Okay, with the help of computers we can do, but directly we cannot interpret. If you see that television, instead of a continuous signal, if you see the television in terms of ones and zeros, what you will understand? You will not understand anything. So you need analog to digital converters and digital to analog converters. Okay, and people say that this is cost effective solutions to solve complex problems. So what is the example? I can give one or two examples for hybrid computers. One is cement plant. Okay, in cement plant, if you see, they are using digital computers to measure the calculation. Some calculations they are doing based on the readings. Okay, they are using analog systems to increase the material in the furnace, or to increase the fuel or decrease the fuel, to control the temperature. Okay, in order to do that, they are using analog system. So they use digital system to measure the readings. Okay, some calculations, and they use, according to the calculations, they come to know that they need to increase the fuel level or decrease the fuel level. Okay, so those things they are doing with the digital analog system. Similarly, in gas stations, in gas pump station, you can see uh, uh, the analog systems are used to measure the gas level. Okay, whereas the calculations are done with the help of digital system. Okay, so these are called hybrid computers.